Hello everyone, welcome to EduTravel Trade. Today we are going to discuss about object-oriented programming and its main pillars of this wonderful programming concept. Let's get started. Object-oriented programming is a programming paradigm that focuses on the concept of objects, which are instances of classes that contain data and behavior. In OOP, the software is modeled as a collection of objects that interact with each other to perform tasks. 4 pillars of object-oriented programming are: abstraction, encapsulation, inheritance, polymorphism. Abstraction is the process of identifying and extracting the essential features of an object, while ignoring the non-essential details. In OOP, abstraction is achieved through the use of classes and interfaces. A class is a blueprint for creating objects, while an interface defines a set of methods that a class must implement. We can look into a real-time example of this for better understanding. A real-time example of abstraction can be a car. A car is a complex object that has many different parts, such as an engine, wheels, brakes, and steering wheel. Each of these parts has its own internal workings and complexities, but from the perspective of the driver, the car can be abstracted as a single entity with a set of interfaces. Here's an example code for abstraction. In this example, we define an abstract car class that has an abstract method start. The gasoline car and electric car classes inherit from car and implement the start method in their own unique way. In the main method, we create instances of both gasoline car and electric car, and call their start method. This demonstrates the use of abstraction, where we can interact with both cars using a common interface, car, without needing to know the specific implementation details of each car type. Encapsulation is the process of hiding the internal details of an object from the outside world, and exposing only the necessary functionality through methods. This helps to protect the object from unwanted changes, and makes it easier to maintain and modify the code over time. In OOP, encapsulation is achieved through the use of access modifiers, such as private, protected, and public. A real-time example of encapsulation in OOP can be a bank account. A bank account is a complex object that has many different properties and methods, such as account number, balance, deposit, and withdraw. To ensure the security and privacy of customer information, a bank account's internal details should be encapsulated and hidden from the outside world. In OOP, this can be achieved by making use of access modifiers such as private and public. In this example, the account number and balance fields are private, and can only be accessed through the getAccountNumber and getBalance methods, respectively. The deposit and withdraw methods are also private, ensuring that these methods can only be called from within the class. This encapsulation ensures the security and privacy of the customer's information and prevents unauthorized access or modification. Inheritance is the process of creating a new class from an existing class, inheriting its attributes and methods. This allows you to reuse code and avoid duplicating functionality. In OOP, inheritance is achieved through the use of parent and child classes, where the child class inherits properties and methods from the parent class. A real-time example of inheritance can be a school system. In a school system, there are many different types of employees such as teachers, principals, and administrative staff. Each of these employees has their own set of attributes and behaviors, but they also share many common attributes and behaviors such as their name, address, and contact information. In this example, we define a parent employee class that includes common attributes such as name, address, and contact information. We then create child classes such as teacher, principal, and administrative staff that inherit from the parent employee class. Each child class adds its own unique attributes and methods, such as teaching subject for the teacher class, number of students for the principal class, and department for the administrative staff class. By using inheritance, We can create a hierarchy of classes that share common attributes and behaviors, making it easier to write and maintain code.
Polymorphism is the ability of an object to take on multiple forms. In OOP, polymorphism is achieved through the use of interfaces and inheritance. Polymorphism allows you to write code that can work with objects of different types, without knowing the specific type at compile time. This makes the code more flexible and easier to maintain over time. One real-time example of polymorphism in OOP is the concept of an animal class that is inherited by various subclasses such as cat and dog. Each of these subclasses has its own unique implementation of the speak method. For example, the cat class may implement the speak method to output meow, while the dog class may implement it to output woof. Hope you understand this topic clearly, and let us know in the comment section if you have any doubts or need more clarity on topics we discussed today. Thank you for watching this video.